Hello, in this video I'm going to talk about parallel vectors. Actually, I'm just going to think through a couple problems. I've extracted these directly out of an A-level textbook, EdXL M1, section 6D, question 6. And firstly, we are told that C, oops, get my pen tool here, we're told that C equals 3i plus 4j, and we are told that D equals I minus 2j, and we were asked to find for part A. There's actually 4 parts this question, but I'll just do a few. So for A, we're asked to find lambda if C plus lambda D is parallel to I plus j. So I'll just write parallel to I plus j. Right. I'm just gonna make that one I plus j. Right. So, okay, as discussed in a previous video, really, I guess the first step here is we just want to write this out. So we know it's C plus lambda D. We need to find lambda. So C plus lambda D. Well, we know what C is. It's right here. So we're just going to write C is 3i plus 4j. I'm just going to wrap that in parentheses now. Plus lambda D. So we can write plus lambda times D, and D is I minus 2j. And again, we can just use the distributive property here and multiply lambda across. So we've got, I'll just write everything out. So we've got 3i, rewrite this 3i plus 4j plus, and we multiply lambda across like so. We get I lambda plus I, or actually let me write it this way, lambda I minus 2 lambda j. And then we want to essentially just collect like terms, if we want to put it that way, and collect our I terms and our j terms, and we can factor out the I or j. In other words, so we know we have 3i, so we can just write 3, it's positive, and our other I term is also positive. It's lambda I, so 3 plus lambda. We can just bring the I out of the brackets. Plus j terms, we've got 4 right here, and another j is negative 2 lambda, so negative 2 lambda, and again we can just bring our j term outside the brackets. Right, now, so we are told that C plus lambda D is parallel to I plus j, and so what we want to do here really is we want to set if it's parallel to I plus j, so we want to set then in that case 3 plus lambda to be equal to 4 minus 2 lambda. And we're solving for lambda, we want to find lambda. So now it's just really simple algebra, right? Because we can add 2 to both sides. That's going to get us 3 lambda, and subtract 3 from both sides. We're going to end up with 4 minus 3 is 1, and then of course we just divide 3 on both sides, and we get lambda equals 1/3. Right, so that's it. We found lambda if C plus lambda D is parallel to I plus j. I'll do another one. Let's do just part B, and we are asked to find mu in this case. So mu if mu C plus D is parallel this one's a little bit different actually, is parallel, is parallel to I plus 3j. Parallel to I plus 3j. Right. Well, the steps are the exact same. I always just like to write things out at the outset. You could probably do this in your head actually, but if you wanted. So new c. So let's just write, and I'll just again I won't skip steps. I'll just make it all explicit. So mu times c. What is c? Let me just scroll up a little bit so we can see. C is 3i plus 4j. And then we're told it's plus d. We know d is I minus 2j. We just multiply lambda or mu in this case across here, and we get 3 mu I plus 4 mu j plus, and then we just rewrite I minus 2j. Right. So again, we just think of it as collecting like terms really. We've got our 3 mu I, and we can just factor out the I like we did last time. So we've got 3 mu, it's positive, plus, and we just have an I here, so we can say just plus 1, and the I comes out. We got plus, and we've got 4 mu, and minus 2, and of course the j comes out. And again, what we want to do is, this case is a little bit different actually. One has to pay attention to the fact that we are told that mu c plus d is parallel to I plus 3j, right? There's a scalar there, 3j. So what we want to do is we want to take 3 mu plus 1, we're going to multiply that by 3. So we're going to write 3 times 3 mu plus 1. We're going to set that equal to j vector. It's 4 mu minus 2. And from this point, that's I suppose that's the key step really, because the rest is really simple. This is just algebra, right? So we're just going to multiply by 3 right across here. We've got 9 mu plus 3, and we're going to set that's being set to equal 4 mu minus 2. Let's subtract 4 from both sides, and we'll add 3 to both sides. That's going to give us 5 mu equals 1. Equals 5, or negative 5 rather. Yeah, so we just divide right across, so we get mu equals negative 1. Okay, I'll just do one more. Let's do d this time, because it looks a little bit different still. Let's we're asked to find, in this case, t. If d minus tc is parallel to in this case it's minus 2i plus 3j. So this one looks a bit more fun. So we've got d minus tc. So just to remind ourselves, d is I minus 2j. So we've got I minus 2j minus t times c. C, of course, this is written here, we know is 3i plus 4j. So 3i plus 4j. Likewise, as the similar problems, we're just going to multiply t right across like so. And so what we get on our second line is we've got I minus 2j minus 3ti plus 4tj, 4tj. It's also worth noting that we're going to have to distribute this negative 1 as well, and so I'll just do that in the next step. But so what we want to do again is just collect our like terms basically, and so we've got I here, it's just 1, we've got a 3t and the 3t is going to be negative, right, because this negative sign is going to be distributed across. So in that case, we've got 1 minus 3t I plus, it's a negative 4t, we've got a negative 2, so negative 2 minus 4t j. Okay, and now we have basically essentially collected our like terms. We are told that d minus tc is parallel to negative 2i plus 3j. So again, we're going to set these equal to one another, and so what we end up with here is 3 times 3. Just think of it as the opposite, right? We've got plus 3j. We're just going to set, if you want to call this our I values, we're going to multiply this by 3. So we've got 1 minus 3t. So 3 times 1 minus 3t. All that's being set to equal negative 2 times negative 2 minus 4t. Right. So now at this point, this is that's I guess you could say that's the hardest part, really, because now we're set up to solve for t, and this is just really basic algebra again, right? So we've got 3 minus 9t equals 4 plus 8t. Let's just add 9t to both sides. That gives us 17t, and we can just subtract 4, so it's going to give us negative 1, and we get t equals negative 1/17.